Hello everyone, today I'll be discussing the pulley constraint and we will be seeing some relation in pulley constraint. Now first of all, what is a pulley? A pulley is a simple machine that is used to carry loads. It can also be used in combination to carry heavy loads. Now a pulley has a wheel, the wheel carries a string. Sometimes the wheel of the pulley is fixed and in other case the string might be fixed at its end. In the first case, we will be seeing a pulley in which the wheel is fixed and we have a string that carries two loads at its end. The block on the right end of the string has a mass that is equal to m1 and on the left end of the string has a mass that is equal to m2. And we need to assume certain things before starting off with the concept. Now, first of all, we need to understand that the pulley has a string that is inextensible. So, inextensible means it doesn't extend. The length of the string is always fixed. Also, the string is taut, which means that the string is tight. It is not slack. Now, I have already discussed the diagram. The question is, find the tension in strings and acceleration of the blocks. We have noted down the assumptions. Now we need to start the problem. First of all, we need to develop some intuition about the problem before starting. Now let us develop some ideas about the situation. Now we have this pulley and there are two masses at the ends of this string. Now, the total length of the string is 2L, such that the half length of the string is L and the other half is L. Here, in this situation, this length is L and the other length is also L. Now, this mass M2 and this is M1. Say for example this case where the mass M2 is greater than M1. By common sense you can say that if this mass is greater than this one, then due to gravity this weight will be more than this weight. So this will try to pull this weight downward. It will move in this direction such that this will move upward. So in that situation, let us assume that this weight has moved by a certain distance, that is x, and in turn this weight has rose by a certain height, that is, let us consider it to be y. Now our goal is to determine the relationship between the x and y. So why I am saying that we need to determine the relationship between x and y? Because this is a distance traveled by this block in certain time. You can consider that, and if you can determine the distance traveled by a certain body in certain time, then it is nothing but a velocity of that body. Okay, this is the distance, x is the distance traveled, and if you differentiate this dx by dt, differentiate the distance with respect to time, which means the distance traveled, small distance traveled per unit time, that is the velocity, nothing but the velocity of that body. And if you again differentiate this velocity, then it is nothing but an acceleration. So that is the reason why rate of change of velocity is the acceleration and the rate of change of distance is the velocity. We know that. So that is the reason why we need to determine the relationship between these two distances, that we can determine the acceleration of the block. Note that in this situation, this string will develop some tension because it needs to support this block. So there will be a tension developed on the string such that it is always pulling in nature. And on this side also a tension is developed on the string. So we'll determine the tension afterwards. First of all, let us determine the relationship between x and y. So what we can do in this situation, first of all, you can see that when this block has moved downward by a certain distance x, the length on this side of the string has increased. That is L plus x. It has become, on this side you can see this is L plus x. The length of the string has increased to L plus x. And on this side of the string, you can say that the length of this string has decreased and it has become L minus y. See, this is total was L, so it has risen by a certain height, that is y. So it has become now this much only, that is L minus y. So initially, while starting the problem, we have discussed that the string is inextensible. What does that mean? Is that the length of the string is always constant. So in this situation, the total length after this situation has occurred, the length of the string has on this side has become L plus x, and on this side has become L minus y. So the total length will be L plus x plus L minus y. That is this length plus this length. That is the total length after the movement of this mass has occurred. That is the total length of the string, and it is constant, which it is equal to 2L. So from here, this L plus L will become 2L plus x minus y is equal to 2L. So 2L and 2L is getting cancelled from both the sides. So if you take y this side, then we are getting x equal to y. So which means that by whatever amount this mass is falling downward, with the same amount this other block will be rising on the other side. That was actually a common sense. If you can use your common sense, then you can say that if this block is moving by a certain distance x, then if the length of the string is not changing, then definitely it has to move by a distance y, because it is just wrapping around. This length is never changing, so it is just wrapping around. So it also could have been determined by a common sense, but we are using some physics and some mathematics to prove the situation. Correct. So we have found out that this will fall by a distance x, and this in turn will also fall by the same amount, that is y. Now if you differentiate this dx by dt, then the acceleration of the velocity of this block is determined, that is equal to dx by dt, and the velocity of this block is dy by dt, which is upward in direction. The direction of the velocities of these two blocks are different, because this block is moving in the downward direction and this is moving in the upward direction, but their magnitude is same. You need to note that thing. So this dx by dt, if you again differentiate this, dx square by dt square, and this is dy square by d square y by dt square. This is the acceleration of mass, which one? m2. This is the acceleration of mass, that is m1. Both are equal in magnitude. Magnitude wise, if this is considered a1 vector, a2 vector, then the magnitude of this vector is equal to the magnitude of this vector a1. Both are equal in magnitude but different in direction. This block is moving in this downward direction, that is a2, and this block is getting accelerated in the upward direction, that is a1. Now in this situation, if you isolate this block such that if you draw the free body diagram of this block m2, then you need to consider all the external forces. That is, this is one of the external force, that is t, and another external force is its weight m2g, and also the block is getting accelerated in the downward direction, that is by a2. Then we can use the simple F equal to ma, Newton's law of motion. Then external forces, that is, it is accelerated in this direction, so we need to consider this first, that is m2g minus, this is t is equal to m2a, a2, m2 a2, because this is a2, it is accelerating by a2. So you can directly find the value of t, that is equal to, you take this t that side, then m2g plus m2 a2. To let us consider in this situation, we have discussed that both the acceleration, magnitude of the acceleration is same, so we'll consider it to be a. So in this situation, you can, instead of writing a2, you can write directly a, that is m2a. And here also, this magnitude, both the magnitude are same, so you can, this is a and this is also equal to a. Now let us consider the other situation in the Pulley constraint, where instead of the wheel being fixed, the rope that is wrapping the wheel has its one end fixed, and at the other end we have a block of mass m resting. In this situation, the wheel can move in this direction, it is free to move, but this end of the string is fixed, and also this end can move in any direction, in this vertical direction. Also, you need to note that in this case, similar to the previous case, the string is inextensible, such that it doesn't extend or its length is fixed. Let the length again be 2L, such that half of its length is L and other half is also L. Here, instead of taking the length from this point, considering the whole half length, we will only consider the length from this point, such that this side of the string has length L and the other side also has the length L. We are not taking this because I'm going to explain that, because no matter where this pulley will reach to any height or it will get lowered, this length is always fixed. This length of the string will never change. This semicircle length of the string that is wrapping the wheel will never change. This is always constant. So we can always add this to the total length and it will always remain constant. We are already assuming that the length is inextensible, the string is inextensible and its length is constant. If we add any constant, then it doesn't make any change to our condition that we are taking. Let's consider that this wheel has moved by a certain height, that is x. Now, what do you think will happen to this string? We can obviously say that this end of the string will rise, and also at this side of the end x amount of string will get added, such that now the length of this side of the string is L plus x. And let at the other end the block has reached to this point, such that this height is y. Block has reached to this height such that this length is y, and the left out length, let it be k. We don't know this length yet. We know that this side is L plus x and this side is k. So in order to determine the value of k, you need to use a simple concept. If you consider this side, then you can see that y plus k is equal to L plus this total length, that is x. You can see that this height, the height by which the wheel has risen is x. So this is the height. So the y plus k is equal to L plus x. So we can write y plus k is equal to L plus x. such that k is equal to L plus x minus y, and on this side of the string we know that its length is L plus x. So if you want to determine the total length after this movement of this wheel, then total length is L plus x plus k. Because this, I've said that this is already constant, this will never change, this was same as that, we just need to consider this length L plus x plus k. So the total length now is equal to L plus x plus k, and we know that the total length is 2L, which is always constant. So in this case, if you substitute the value of k, then you will be getting this equation, and here the magic is happening. If you see that this L plus L will add up to be 2L plus x, there are two x terms that will add up to be 2x, and it is y is equal to 2L. So this 2L and 2L is getting cancelled, so you can see that 2x is equal to y. So in this situation something different is happening, where if you are raising the wheel by a certain length x, then this block is getting in turn moved by twice this x, y is equal to 2x. So this is a very important result. Now we can determine the velocity of this wheel, because velocity is nothing but distance traveled by this wheel in certain per unit time in 1 second. So if you differentiate dx by dt, then it is the velocity of this wheel which is in this direction, and if you differentiate y, then it is the velocity, because velocity of this mass. So dy by dt is the velocity of this block, because the block has risen by a height of y in 1 second. If you differentiate on the both side of this equation, then you can see dy by dt is equal to twice into dx by dt. So this implies that 2 times the velocity of this wheel is equal to the velocity of the mass or the block. And also if you differentiate the velocity with respect to time, then you will get the acceleration such that twice the acceleration of this wheel is coming out to be equal to the acceleration of the block. You should not confuse that. I have taken in this case velocity of the wheel as Vb and the velocity of this block as Vm. So this is an important result in this situation, and the tension is again always pulling in nature. So this here tension will be developed on the string such that it will try to pull the wheel in this direction, and also an equal and opposite tension will develop on the string in this direction. At the other end also it will be same, so both the side the tension is always the same. So if you see this here, if you try to isolate this block in this situation, then the mass of weight of the block is acting in this direction, the tension is acting in this direction, and when the wheel is moving in upward direction, then this block will get accelerated in this direction with acceleration of this mass. This is that is am. Now this is the acceleration of this mass, and we can use again the simple F equal to ma equation to determine the value of tension in this situation. That is, block is moving in this direction, so T minus mg would be equal to am. So if you use this equation, then you can find the value of tension in this case. So in this way we can determine the acceleration of the block as well as the tension in the strings.